So previously we were discussing normal SQL queries, and now moving on to advanced queries that are join queries. So there are join is basically a Cartesian product followed by a selection operator and a projection operator. So in terms of, if we are talking in terms of relational algebra, so it is a combination of Cartesian product, selection and projection operator. There are two major types of joins. One is outer join, one is inner join. The difference between the two will be the inner join will contain only those records which are part of the selection. Outer join, it will include those those rows as well which are not part of join. So basically the inner join selects all the rows from both tables as long as there is a match between two columns. So looking at this Venn diagram, if you see there are two tables and this overlapping area is common between the two. So if we are to apply inner join, so it will return this specific portion. So for example, if we have table of customer and we have a table of job, and if you see here customer 1, we have customer 1 here, customer 2, we have 2 here, customer 4, we have 4 here, 5, we have 5 here, but 6 is not available. So if we have to apply inner join, so inner join will join the records which are common in both the tables, like 1, 2, 4 and 5. So 6 will be exempted. Why? Because there is no common between the two tables. So inner join example, how do you write the query? So for example, if we have the student table and we have the course table, so for example, select table 1 dot column 1, table 1 dot column 2 from table inner join table 2 on the matching column. For example, if we have table 1 student, table 2 course, and what are the common between these two? So we have to apply the common on roll number. So the query will become select student course dot course ID, student dot name, student dot age from student. Inner join student course on student dot roll number is equals to course dot roll number. So if you look at here, roll number 1, it is available here. Roll number 2, it is available here. Roll number 3, it is available here. Roll number 4, it is available here. Roll number 5, it is available here. But 6 is not available, 7 is not available, 9 is, 8 is not available. So 9, 10, 11 is not available. So the first 5 will come. So first 5 is, for example, Harsh, Pratik, Priyanka, Deep and Saptarai. So these are the 5 matching records which will be the output of inner join query. Why? Because these are the common rows that exist between these two tables. So theta join, as we discussed in relational algebra, it is when we use the in in the clause, when we use greater than, less than, greater than, equal to, less than, equal to. So that is basically known as theta join. So for example, if we have the two tables, we have the customer table and we have the cost or the budget table. So we can see select item name person budget dot name from item comma person budget. So it is if you are not applying the where condition, as we have discussed in class as well. So basically Cartesian product is when you are doing a join but without a where condition, because we are not selecting a where condition. So what it will do, it will instead make the uh, Cartesian product, or it will make the pairs of both the tables. So if we are doing select item dot item name person budget dot name from item comma person budget, what it is going to do is it is going to make a Cartesian product of both the tables. So we can also if we have to add theta join, so theta join will be where we are applying a condition which doesn't contain equality, and instead it contains greater than, less than, equals to, greater than, equals to, not equals to, something like this. So if you see here, this is basically theta join condition, that the item cost is less than percent budget. So this is an example of theta join. Equijoin is when we are using equality in the condition, in the join condition, that is known as theta join. That is known as equijoin. And when we are using greater than, less than, those operators, then it is known as theta join. So the example of equi-join will be, for example, if we are to join the two tables on equality sign. So if we are using equality sign, it becomes equi-join, and if we are using greater than less than sign, then it becomes theta join. Natural join, as discussed in the relational algebra, natural join is when we don't have to mention the matching columns. A join that projects out one of the matching column is known as natural join. So, for example, if we have two tables and there is a matching column, we don't need to mention the join condition. Like previously, we were mentioning the join condition on inner join, like inner join table 1 dot attribute 1 is equals to table 2 dot attribute 1. So that condition doesn't need to be mentioned here. Why? Because we are using natural join, which automatically joins the two tables. So for example, if you see the two tables, the student table and the marks table, we can simply write select static from student S natural join marks M. So S and M are basically aliases, if you remember. So we can use spaces between them, and we can also use as. So if you see here, roll number becomes here, name and marks are joined here with the help of roll number. So we don't need to mention the column. Why? Because we are using natural join, and it contains both the table contains one similar attribute. Outer join means when you get the records that are not even matched. So outer join has multiple types. So we have left outer join, right outer join, full outer join. Outer join means if we are using R1 join R2, it is similar to natural join but keeps all the dangling tuples of R1. What is dangling tuple? If you see dangling tuple means usually only a subset of tuples of each relation will actually participate. Tuples of relation not participating in join are dangling tuples. So outer join means we will keep those tuples as well which are not part of join. So we'll keep the record of left. In right outer join, we'll keep the records of right table, and in full outer join, we'll keep the record of both the tables. So left outer join means keep the matching records of both R1 and R2, and unmatched records of R1 as well. Right outer join means keep the matching record of R1 and R2 and unmatched records of R2. Full outer join means keep the matching records of R1 and R2 and also unmatched records of R1 as well as R2. So left join is basically A join B. So the result of left outer join will always contain the record of all the records of the left table, even if the join condition does not find any matching records. Why? Just we discussed before that it will keep all the dangling tuples of A over the left side of the table. So for example, if we have example here, in previous example, we only find the first 5 matching rows, but now we'll also get the record for 6, 7, 8 as well. If you see here, you are getting the left table as well. Why? If you see here, we have from student left join student course. So student is left table and student course is basically right table. So it will keep the dangling tuples of the left table as well. So moving on to right side, so it will now include 9, 10, 11. Why? Because the 9, 10, 11 roll number uh, don't have any matching records here. So 4, 5, 4 will come from this right. So if you are using full outer join, so for the full outer join, it will be showing the records from both the tables. So inner join, it will contain records only of the matched column. Natural join, it will only contain records from the uh, matching columns, and outer join will contain records from all the tables even if it is not unmatched. So if it is left, it will keep the tables of records of left. If it is right outer join, it will keep the records of right outer join, right table. And if it is full outer join, it will keep the record of both the tables. So this is basically both the joins, inner and outer join.